Now in this lecture, we're going to be talk about how we can design the PV array for our project. We have seen in the last lecture regarding the storage system, how we are selecting this particular battery. Now we're going to be select the PV array over here. So whenever we see the PV array, actually as per the software, they are giving us the configuration that suggested capacity of battery and suggested PV power of 2662 watt peak. So this power has been given to us and we'll have to design the further parameter as per our requirements. Now, whenever we are designing the PV array for our solar system, some of the important points we have to be remember. So we just come to the Excel sheet, we're going to be see over here. As per our calculation, we have a total daily consumption is 8530 watt hour, ampere hour of a battery that we have selected. Now we have to calculate the expected PV power. Now how to calculate the expected PV power? This we can calculate that what is the basic consumption of a consumer is there. So let's say the consumption of a consumer is that equal to, we take a total daily consumption. Here we're going to be add the overload factor or the future expansion factor or any kind of equipment the consumer is adding further. So it also able to sustain, or solar power plant also able to sustain to provide the electricity to that particular equipment. So that is why we are taking the overload factor is 1.3 over here. We're going to be take it like this and we just close the bracket. So this is a daily consumption as per the current requirement with overload factor, and this will going to be divided by 4000 because as per the thumb rule has been consist, it says that 1 kilowatt of an solar system will generates 4 units on an average daily basis. So this 4 units is measured in terms of kilowatt hour. So that is why this unit has been given in terms of an watt. So we'll have to be convert that 4 kilowatt hour into the watt hour itself. So that is why 1 kilowatt is generating the 4 number of a unit in a one day. We just multiply by 1000. So kilowatt has been converted into the watt hour over here. So like this, the expected PV power into overload factor divided by the 4 kilowatt hour generated by the 1 kilowatt. This thumb rule will going to be used. From this we approximately come to know what should be the expected PV power or photovoltaic power we should install on a site. So as per the mathematical calculations, we have 2.77 kilowatt hour kilowatt peak, that is a expected capacity of photovoltaic power plant. In terms of a watt, when we measure, it is a 2772.25. This is a capacity in terms of an watt peak whenever we just compare this particular unit value over here. Suggestion has been given by the software is 2662. Rather we can just go for it, or as per our calculation we can just change into it. So for that particular purpose, we'll have to just write here, enter the plan power. So whatever the calculation part that we have done, so we just keep that power 2772.25. So we just enter this this watt peak of an power. Now we're going to be design the further parameters. So here we can design the solar power plant with the help of the available area also. Let's say we have a 10 meter square of an area. So in a reverse way, we can design the power plant. But we are dealing with the standalone type of an solar system. So that is why we have to be just calculate the consumer requirement, and according to that, we'll have to be design the PV power. Once we have done it, we'll have to be select the PV modules, that which PV module or which manufacturer we have to choose. So let's say we just choose the available now, and from that we're going to be select any kind of a manufacturer, what the solar panel easily available where we are installing the solar power plants. So let's say in the lower side, we're going to be select the manufacturer, and then we're going to be enter the capacity of the solar power plant. So it will going to be just install, or it will going to be just take a time whenever we are just selecting this particular power panels. So now here the different manufacturer has been given. If anyone has not been given, you can just enter into the database also as per your requirement. So let's say here we're going to be take the panels of an Trina Solar. So I just take it as an power of an Trina Solar. We'll select the manufacturer. In a Trina Solar, we're going to be take the solar power plant. A different wattage capacity is been given. So we'll take an polycrystalline technology, and that to be of the for 240 watt peak of an solar power plant, we're going to be take it over here. So once we just take it over here, the software is downloading it's everything regarding the open circuit voltage, short circuit current, everything parameter it is downloading. You can see the data sheet in the open also. So what is the specifications of a parameter are there for the panel. This is a 240 is a nominal power, and this is a reference condition, short circuit current 8.8, open circuit voltage 37.40 at a reference temperature of 25. Maximum power point current is 8.14. Maximum power point voltage is 29.50. 60 cell are connected in series. So like these parameters, you can just check it out it over here. And here also you can just check the size and technology. What is the module length, width and height is there. What is the series combination for the cell will be there. What is the IC maximum voltage, it has been there. Module parameters we can check it out over here. That is a IV curve we can just check over here. So like this we just check it out, this parameter we can just have a graph of these modules like a power volt versus voltage, efficiency versus irradiation, like this. We just come to the basic data. We'll just going to be just okay now, and we just note down this parameter. So approximately total module needed for this plan capacity is 12 modules. Then what is the maximum power point voltage at the 60-degree temperature is 25.1, and open circuit voltage as minimum temperature is 41.5 voltages. Though we know that open circuit voltage is 37.5, but as good as the temperature is decreasing lesser than 25 degree, let's say the 15 degree, 10 degree, 0 degree, minus 10 degree also. So in that case the open circuit voltage of a solar cell is increasing drastically, and according to the testing condition it has been given over here, the open circuit voltage at a minimum temperature is increasing max to max 41.5. Similarly, if a temperature is increasing beyond 25 degree, 35, 45, 60 like this, then the maximum power point voltage of a solar panel, it is decreasing as per its original capacity. So that is why software is also calculating this according to this particular temperature. We're going to be note down this parameter. So we take the Excel sheet, and in the Excel sheet we note down the parameter, that is a panel VMP as per the calculation is 25.1. Panel open circuit voltage is 41.5. We just note it down over here. Thereafter, how many number of modules are required, this we can calculate by this formula. What is the expected PV power that we have in terms of kilowatt peak, multiply by 1000. So we convert this value into the watt peak divided by what size of an panel that we are using, 240, 250, whatever that we will use. Just divide by this particular value, and from that we are getting the answer as 11.55. We just close this value up to the 12. So the total 12 number of an panel that is required to satisfy the given capacity. Now we're going to come down to the controller selection. So basically we're going to be use, if we are dealing with the DC system, you can use the DC to DC converter. So the inverter is not been required. Then the direct coupling will be there. So in terms of an solar pumping system that we are using direct coupling, or if we have a NPPT converter, nowadays smart technology are coming. So we just select the NPPT converter, inverter parameter that will going to be select. So controller is nothing but the inbuilt NPPT converter, and this will going to be invert the power from the DC to the AC power also. So we just select the NPPT converter, but before that we just untick mark this particular universal converter. Here various manufacturer has been given us over here, and from that whatever the size of this controller will be required, that will going to be select actually. Before we can select the controller, we'll just come down to the Excel sheet and we'll see how we can select the controller sizing. So basically whenever we want to select the controller sizing, some of the parameter we have to be understand. So basically the first parameter is that what is the overall wattage capacity that the equipments are having. So let's say whenever we just come down to the step number 1. So here we'll find we have a LED, then with tubes we have a television, fan, washing machine, refrigerator. So consisting of their all the quantities, when we see actually overall wattage consumption by this equipment, we have a 60, 100, 350, 550, 150, and overall wattage including their quantity also, overall wattage is 1210 wattage actually. So this much wattage capacity the all equipments are having. It means that at the same time if we are switching on each and every equipment, then this much amount of the wattage the inverter should handle on this particular situation. So that is why this net wattage capacity we have to be consist whenever we design the controller for the solar power plant on the standalone system. So whenever we just construct this particular formula, so we're going to be construct like this. So we just write a equal to, we just make a bracket, then what is the overall wattage at the same time we require for this equipment. So we just select this, plus we are using the 6 numbers of an battery who is having the ampere hour capacity of 444.27 as per the calculation. So we have a 6 number of an battery, so we just write the 6 multiply by charging current for each battery is 15.5, that is a C10 battery we are using, which is having the 155 ampere hour. So that is why we write the 15.5 as an charging current multiplied by the voltage of an individual battery. So this will going to be consist. It means what? The current and the voltage. This is a wattage capacity of a battery, and total number of a battery that will have a 6. It means that with all equipments are running at the same time, plus all the batteries are charging at the same time, then what is a maximum wattage handled by the controller? It should be this much amount of a wattage, that is 2326 watt, this much at the same time. By chance if we are switching on each and every equipment at our home, plus we are charging the batteries, then controller should not be tripped in that particular situation. And that is why we'll have to be careful whenever we are selecting the controller sizes. So that is why the wattage handle plus 6 number of a battery charging at the same time. So we just consist this particular parameter multiply by, we multiply by the overload factor. So if any equipment newly has been added and that also has been on at the same time, then the controller should not be fail in the particular situation. So that is why the overload factor we have to be multiply by 1.2. This we just divide by the efficiency of an inverter or the controller. So the each and every controller don't have the 100% of the efficiency. Some of the power is getting lost to convert the DC power into the AC power. So most of the inverter is having the efficiency of 0.98. So we just take it as that. This efficiency we can see in the datasheet also whenever we are selecting any controller in the particular situation. So we just write this particular formula and we click on enter here. So we are getting on an average the controller size will be 2848.16 watt. This much will be the capacity of an controller or inverter, whatever we are selecting for the particular project. So on an average when we see, at least we require 2880 watt of the controller sizing for our project. So similarly now we're going to be search this controller in our database and for this particular wattage capacity. So we just write all manufacturer and we just going to be search. If it is not there, whatever the controller we are using as per the market size, we're going to be write their data sheet into the PVSyst software. So whatever the system will going to be take and then we're going to be edit their parameter. So we just search for 2880 watt capacity of an controller. So whenever we search here, the various type of an watt controller has been given. So as per our need, that will go to be select. So this controller we can able to select over here. So I'm just going to be select this particular controller. Once we have taken this, now we can just see it over here. The maximum input operating voltage is 75 and 145 voltage. We have this 140 is the input maximum voltage and controller power is 2.88 kilowatt. So this is the power has been given over here. But now whenever we are talking about this particular NPPT converter, its voltage has been given to us as an 48 volt. So though it is a satisfying our capacity, whenever we see it over here, we'll find their voltage is a 48 volt. So we have to be match this voltage also because we are dealing with the standalone type of the system. We have used the battery voltage as an 24 volt. So this system voltage also able to handle the battery also at a charging current of the charging voltage of a 48. So we'll have to change the inverter over here. So once again we're going to be see the inverter in the same capacity, but it is a 24 volt so that it could be matched with the system also. Or it should be compatible to our batteries also. So let's say these are the 24 volt converters has been given, or the controller has been given over here. So we can use the 2 controller, 3 controller as per their sizing also if you are not getting the same capacity. So we just select it over here. So let's say this type of a controller, if we are selecting, this is a 2560 watt capacity, which is a close to our selection. We'll see further other parameter also. If you are getting the higher capacity, okay, so we are getting this capacity like the 2900 watt, which is having the 24 volt, which is compatible to our battery bank also, but it is slightly oversized, but that is also okay. If it is a slightly oversized, it satisfies our demand. So future point of view also, it has been essential to design the higher capacity of the controller. So we're going to be select this controller as per the capacity. And now when we see the particular data sheet of this controller, we'll find the maximum charging current, maximum discharging current, converter nominal power. We have a self consumption of an controller threshold limit. When we see this, the threshold limit has been given, NPPT converter has been given. Then we see the efficiency profile also for this. So we'll find this particular efficiency profile. It is having the 99% of the efficiency. Other data and sizes, when we see this parameter like the size of this particular controller, commercial data also has been given over here. So we just confirm this particular parameter. On lower side, when we see in the general data, system battery pack, technology lead acid battery can be compatible, vented and tubular. Battery pack voltage is 12 volt and it is suiting. It should be written over here, suited and okay. Battery pack capacity is 155 ampere CTN battery. So whatever the battery we are using and whatever the voltage of battery bank we are using, it should be compatible with our controller. Then our system will going to be work in proper manner. So it is written suited and okay. Then we just going to be just okay over here. Now, when we just note down, we have to be note down this parameter also. What is the minimum acceptable voltage on the DC side, maximum acceptable voltage on the DC side also. We just note down this parameter on Excel sheet and we'll see the further parameter, how we can design it. This is the minimum voltage, 245 is the maximum voltage. Okay, now whenever we have to be design that how many number of a solar panel we have to be connect in the series combination, rather panels in the parallel combination. So minimum number of a module that we are connecting is nothing but the minimum acceptable voltage of our controller divided by maximum power point voltage of a particular solar panel. From this we'll find minimum number of a module that is required is 1.55. But if we are taking the round off as an 1, then the voltage what we are getting, then the system will not going to be work in that manner. So that is why we just round out up to the 2 over here. So that if we are connecting the 2 panel, then system can able to start. Maximum module that we can connect is nothing but the maximum acceptable voltage of a controller divided by the open circuit voltage of an panel. And from this we are getting 5.90. This is the maximum solar panel that we can able to connect in the series combination. But if you are rounding this parameter up to 6, then the what is at the STC condition, a very ideal condition, whatever the voltage that we are getting from the panel, it might be the chance that it will going to be exceed the maximum limit of this particular parameter. So we just round out up to the 5 for the safety condition. We can round out up to the 6 also, because when we see the input maximum voltage, it is acceptable up to 250 also, 250 volt also. So that is why, but for the safety condition, we just take it as an 5 and we design this particular project. So now, whenever we come down to the PV array design, we'll find that software is showing us number of modules in the series string combination. So the module in a series between 2 to 6 and module in a string that is of 1 to 3 string, we can able to select it over here. So let's say if I am choosing the 5 number of an module that we are connecting in the series combination, then if you are taking the 2 number of a string, so we are getting total 10 number of a PV module, but actual requirement is 12, so it is an undersized project. So it is been written over here, controller power is oversized and this panel capacity will be undersized. Now we're going to be increase the string and we just reduce the number of a panel in the one string. So let's say there are 4 number of a panel we are connecting in one string, which is satisfying the capacity of a minimum and maximum module, that is the optimum number of a module connected in the series combination. So we have a total number of strings are 3, total number of a panel in one string are 4, total number of modules are 12 over here. So now it will going to be satisfy our capacity, and total number of area is required, that is a 20 meter square. So now whenever we see this particular capacity, array nominal power will be 2.9 kilowatt peak, and maximum operating power at a very ideal situation, it is 3.3 kilowatt over here. But actually whenever we just select this particular power, the maximum power that can go up to the nominal condition, standard test condition, it is 2.9 kilowatt peak, which satisfies our capacity. And now the same thing, whenever we just want to draw, so we can draw this particular parameter here also. We just understand here how this parameter will going to be just connecting over here. So let's say if we are connecting the 4 number of an solar panel in the series combination as per our calculation. So this is our string number 1. So we just write it over here, string number 1. Similarly, we have the 3 such strings are there. So we just write this particular combination, and this is our third string. This will going to be take it over here like this. So each individual solar module is having the VMPP voltage. Whenever we see individual solar module, it is having the VMPP voltage is 25.1. So we just write it over here, 25.1 volt multiply by 4, because in series combination the voltage will going to be increase over here. So whenever we try to calculate this value, so as per our calculation, we take a calculator, 25.1 multiply by 4. So minimum voltage of the string is at least 100 voltage that we are getting, minimum voltage 100.4 volt, and which is the acceptable capacity whenever we see this particular ranging of this voltage 29 to 245. So 100 is within that. So the solar power plant will going to be work in the proper manner. Again, similar condition will be there for second string also, that is a 100.4 volt. This is also 100.4 volt. Now we just check it out the current actually. Whenever we open the data sheet, we'll find the current of an individual module is near about 8.14 ampere over here. So whenever we take this current as an 8.14 ampere, the modules are connected in the series combination, and that is why the current that we are getting in a string number 1 is 8.14 itself. The current will not going to be changed because in the series combination, here also 8.14 ampere, here also 8.14 ampere. So like this, whenever we are combining this particular parameters like this, so we are getting the string wise, this is a voltage for this particular case. Further, we'll going to be see how it will going to be connected into the controller, whether in the series connection, whether in the parallel type of an combinations over here. So like this, we can able to understand how we can able to design actually this particular number of capacity. So we can just write it over here, string connection in the series. So totally in the series we have 4 panels, in the parallelly we have 3 panels, 3 parallel connections that will going to be take in a one string over here. We just write in the Excel sheet, and now the further parameter will going to be study further.